Okay, so this is just a breakdown of the code that I've got running on the Arduino. This will just be a short video. I'll quickly go through it. If you're interested in any parts of it, just pause it and copy it down. So this is just the libraries that I've used. You can see the first two are obviously for the OLED display. This one here, the energy IC, that's for the smart meter chip that I've got in there. Again, then you have the AD9850. That's for the sine wave controller, the SPI, the I2C libraries. Just more about the OLED. I do have an interrupt button, but currently not using it. RGB LED I do actually have on there, but at the moment it's taken off because I keep moving boxes. More for setting up the sine wave generator. I've set some sort of limits for the voltage. If the voltage is above a certain amount, it will cut off. Moving down, just some variables to store the meter readings in. A default frequency for the sine wave generator. This is the calibration for the AD9851. This is volt and fine. That's just how I'm setting the voltages. A default phase is 0, so it's in phase with the clock. Just a count, because basically what I'm doing is I'm looping it around and counting up, and every time I get to a certain amount I'll do something. So we actually just keep going through loops. You'll see what that's for. Val, you'll see what that's for. Encoder, pin A and pin B, that's for the rotary encoders. More stuff for the rotary encoders. This is for where I've set things. You'll see in a second. I've got some more stuff for the limits. Alright, so I'll quickly pan through and I'll speak about anything that's pretty big. So we're getting up to the setup. Alright, so basically when this is true, it means I can control the knob at the front. So I generally had that at false, but it meant I have to keep turning it on from the computer, which I got a bit over, so I've made it true for now. Stuff for the display. Now I'm going to replace all that with a 16:4 display, so I'm going to get rid of all this stuff. So this is just in there temporary now until I get round to the new box. Setting up the pins, more of the DDS, so the AD985051 thing. Setting up the serial port, the SPI, get beginning. This set color, this is for the RGB LED. Now I'm just this CS pin low is for the digital potentiometer I've got in here. Now this just makes them both at 0, so basically prevents any output if it was to occur. Again, more pin stuff for the encoders. Energy IC, that's the smart meter chip again. I'll put a link down the bottom of where I got that from, and you can see that there's a library there available if you're even interested in that. Now this is obviously where the loop starts, so just more declaring some stuff. Like I said, as it runs around, in this case it's the loops counts along, and it increments, and then when it gets to 10,000 it will go ahead and do this. And this is just because I can't update the display so fast, but I'll fine tune that down to be as fast as I can without losing any performance. Displaying update, so that was the end of the delayed bits, but then I've got a second one, so when it's 40 it does this. Now this is well, I've got like a set voltage thing, so I can say give me 100 volts and it'll move around the 100 volts, and that's what all this stuff is for. These are all the variables for that, and you can see how it's kind of working. So I'm getting the voltage from the smart meter chip, and then I'm like, oh, but VSET1 was this, and then oh, if it's less than this, and you've got to go up this way. If it's greater than that, then you've got to go down to this. It works quite well. That's all those delayed functions. Now this is just if the encoder's moved. So if the encoder moves, then it just prints its position. But done. I've got that all sort of commented out. Now this is what happens if I check. The serial port gets checked every time it runs around. Now if there's a message from the computer, it will read it, store it as Q, and then if the Q equals all these different things, it's going to do something. So that's if I use it with V or LabVIEW. VS, that's because I'm going to use it in collaboration with some other software that I've made. Serial numbers, manual voltage mode, auto voltage mode. It enables, set some limits, so on or off. That's obviously checking what your limit's set to, because you can adjust it. Now if you set a center frequency, so if you write F and then a number, say 50, 60, 100, 2000, whatever, it will then send that off, and it'll get going. And then obviously it just updates the display with that. And that's this coarse voltage control. So I can set so basically I've got a two-channel pot and it feeds into each other. So one goes up, the other one comes down. I haven't quite finished the coding for that, but it works. So that's the fine part. Let me just show you quickly. So that's the fine part. There you've got phase control. It's getting a bit long. I'm up to 6 minutes. Read statements. So this is, turn the wave on, calculate what the impedance is, get the current, get the volts, get the active power, reactive power, get power factor, get angle, get hertz, get VA, down 1, up 1, if that's just potentiometer settings. Dump stats. I've got a function which is all these. Dump 2, which is all these. I'm using dump to update the screen. In my last video, you'll see there's a picture-in-picture. That's what that is. It's for that. So it just turns it off, and then see that the dump stats. It all prints it on one line. This ZXS is for the computer. So if the message contains that, it knows where to put all the stuff. So how quickly I can move up and down. So these are all just the same with different numbers. Up 200. Then I've got the downs. Nothing really special. How to calculate the impedance. Calculating the X and Y. So Y being admittance. Angles, this is all getting it from the thing. Now, I haven't quite fixed up the angle. I've got a problem with the angle, but I just haven't got around to fixing it. Voltage levels, frequency, active power. So this just gets all the individual things. That's what's get called. And it all happens pretty much instantaneously. So it's pretty quick when you ask for all those things. So that's just a set color for the LED. Manual voltage setting. So basically, it runs that every time you shift the knob. This is obviously for the interrupt. I'm not really using that at the moment, but I will. Yeah, that's it. Anyway, if you've got any comments, just add them at the bottom. I can get back to you if you've got any questions or whatever. But otherwise, just pause it when you need to if you're even interested. Alright, thanks for watching.